Alright, these first two videos are going to be from lecture 5.2 and 5.3, which you will find under notes and outlines on MyLabs Plus. And you'll want to scroll all the way down to page 8, so I'm going to do page 8 and page 9 here since we did not get to those in class. And over here on this box, this information will help you with the homework questions in 5.3, numbers 8 and 9. Okay, so what we're going to do with these problems is we're going to use the definition of a logarithm to go from exponential form to logarithmic form and from logarithmic form to exponential form. So kind of continuing what we did in class, we need to be able to go both ways when using this form. So we have y equals log base a of x such that a raised to the y is equal to x. And we are going to go from exponential form to logarithmic form first. So in number A here where it says 16 equals 2 to the x, we're going to write this as a logarithm. So you can use the definition and you can see where all the pieces match up. But if I were to walk you through the meaning of this conversion, the first thing you want to point out is what is the base of the exponential equation. Because the base of the exponential equation is going to be the base for the logarithm. So this one's going to be log base 2. And then the point of the logarithm, which we talked about in class, the whole point is to find the exponent. So on the other side of the equal sign is going to be the exponent, because that's the whole point of using logarithms, is to determine whatever the exponent is. So the only place we have left to put 16 is right here after the logarithm. And you can see that that matches up here with the x part of the definition, 16. And just to make sure that you're writing these properly in your notes, because sometimes it's hard to tell what's a subscript, what's normal, and what's a superscript there. But all this is on one level there, the log 16 equals x. And then the 2 would be written as a subscript. So similarly, if we went to letter B, where it says 10 raised to the negative 3 is equal to 1,000th, then we're going to write log base 10, because our exponential equation has base 10. And the point of the logarithm is to find the exponent. So negative 3 is going to be by itself on the right side. And then we're going to have 1,000th right after the logarithm. And for our last example here, we have base e. And remember, we talked about that in class, that e is a number. So we can look at that right away and know that it's not a variable. So we have log base e is equal to t, okay, because the point of the logarithm is to find the exponent, so 70 would go right here. Now, just as a little extension, we're going to see this on the next video, but log base e is actually a natural log. So the best way to write this would be natural log of 70 is equal to t. Okay, because that's just a definition. Log base e is equal to natural log, but we will talk about that again in the next video. All right, now we're going to work the other way. We're going to rewrite our logarithms in exponential form, and this is what we did in class. But we're going to do it again, and I'm going to show you a sketch that's going to help you remember how to convert this if you don't remember the exact definition. So let's use the definition first. Remember, the base of the logarithm is going to equal the base of the exponent. So we're going to have the base of 2. The point of the logarithm is to find the exponent. So 5 is going to be our exponent. And of course that's going to equal 32 because we know 2 to the 5th is equal to 32. So the little sketch we can use to help us convert that quickly, instead of having to recall the definition, is if we circle the base and we draw an arrow around the right side of the equation. This helps us note that 2 raised to the 5th is equal to 32. So we could do that here on letter B, where it says log base A of Q is equal to 8. If we circle the base, draw our arrow around, we're going to have A raised to the 8th power is equal to Q. And similarly here in letter C, we have X equals log base T of M, but we can see our constant is on the right side, so we're going to have to draw our arrow the other way. And this conversion means that T raised to the X power is equal to M. And you'll see me use that a lot as we continue on in our examples with logarithms, to use that sketch to help us convert. And remember, this is going to help you with homework section 5.3, numbers 8 and numbers 9 specifically, but it will also help you with numbers 1 through 7 before that.